you guys work with. Okay, there's more than that that exists. You know, if you get into the actual trig class and you work with full trig functions, there's going to be more than exists than what we talked about. But even the other ones that exist that we use are all related back to these three main ones, which are just called the sine, cosine, tangent. If you have a scientific calculator, guys, you'll see these on there. The SIN button, COS, that's what those are. And if you did like the sine of a particular number, if you did sine of 40, or sine of 2, or sine of like 88, or something like that, your calculator should return a number back to you. Should be a decimal less than 1 if you're doing like a sine value. Okay? Now, each one of these ratios, they're just ratios of the sides of a right triangle. And to start with, all we're going to do is we're going to go through what each ratio is, like by definition what it is. And then just work on setting up some fractions first, just ratios yet, before we actually do any applications with it. And the applications will be simply using these to find side lengths to start with. Okay? At the end, we'll do the angle metric stuff. All right? Now, these three right here, by definition, the way these go. And these are all the words that are going to be up here are all in relation to an acute angle in a right triangle. Okay, so the sine ratio, sine of an angle, and again, this is, when you read this, I know it doesn't have it up there, but this is like sine of an acute angle equals opposite over hypotenuse, meaning the value of the side opposite that angle divided by the value of the hypotenuse will give you that ratio. Okay, so sine is opposite over hypotenuse. Just write these down first, and we'll go ahead and fill them out. All right. Cosine is the side adjacent to the angle, which is the one right next to it, over the hypotenuse. Tangent's opposite over adjacent. Now, like I said, what these are, okay, when I say like opposite, adjacent, hypotenuse, it's all in relation to one of the acute angles of a right triangle. Okay, you're not doing it with the right angle. Like, so the right angle automatically should get thrown out. All right, you guys are simply dealing with these in terms of right triangles. So these ratios, as they sit up there, are all in relation to one of these two angles. So if I looked at like angle C, and I was doing like the sine of angle C, or the cosine of angle C, or the tangent of angle C, what I'm asking you to do is write out the ratio of each one of those in relation to this, such as if I'm looking at this angle, this side right here would be directly opposite it. This would be your hypotenuse because it's the longest, and that'd be adjacent. So if I wanted to fill in these ratios using what's up there, if I said I want the sine of angle C, I'd take whatever values on this side, divided by whatever values on that side. You're probably not actually going to divide it out. You know, to start with, you're just going to leave it as a fraction. All right. When you actually do the work to find side lengths, you'll have that already divided out for you. Calculator kind of takes care of that. Okay. Now, before I get into like writing them out, you know, just doing the with numbers and stuff, not actually solving anything yet, no application. Usually, if you go through this, they write out one word to help you guys kind of remember this. Has anyone done this before? Has anyone done sine, cosine, tangent stuff before?
I think I remember doing it, but I don't remember how.
You don't remember, like, I'm just with this. Do you remember like the word thing that they use to help you remember this?
No, I remember
Yeah, you know, they usually what?
What does it say on the left side of the triangle between A and B?
Opposite.
Opposite.
They don't. I'm gonna write it. Like there's a little word that you can write out to help you remember it. It's SOHCAHTOA, meaning sine is opposite over hypotenuse, Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, this is just, and all that is just to help you remember, right? I have both front and back different mnemonics. That's like a mnemonic, right, to help you remember things. Different ones that I've gotten from various places. Okay? Just to show you an example, if that's not the only way to help you remember these, if you come up with your own, it'll work the best. And all it is, like the SOHCAHTOA thing is just sine. The O stands for opposite, the H is for hypotenuse. The C is cosine, the A is adjacent, H again is hypotenuse. Okay? But like the ones on here were just ones that I found in various spots. Okay? Like usually when I give this out, some people pick ones from here to help them remember what each part is. Because in order for you to actually use these things, you have to remember what the exact ratio is. Like you have to remember sine is the side opposite the angle over the hypotenuse. You have to remember the tangent is the side opposite the angle over the adjacent side. So on. Okay? So I honestly do not care how you remember this. Come up with your own thing. Pick something on the sheet I gave you. Use this. Doesn't matter. Okay? As long as you can remember it so that when we do the applications of it, you can set the problem. All right? Now, what I've been saying, okay, is what's written up there now. If I ask you just to simply write out the ratios, sine, cosine, tangent, right? The words opposite, hypotenuse, or opposite and adjacent, are always in relation to one of the acute angles, right? And again, you're never doing like sine, cosine, tangent of the right angle, okay? You're just simply looking at acute angles for what we're working with. All right, so if I asked you, like, I gave you that triangle and I said, I want you to write out the sine of angle R, the cosine of angle R, and the tangent of angle R. Okay? Basically what I'm asking you to do is just take whatever the ratios were, by definition, like opposite over hypotenuse, adjacent over hypotenuse, so on, and plug in the numbers that are up there accordingly. Okay? What I'd suggest you do, and I kind of have this written out when we actually do the problem solving stuff, or finding side lengths. Whichever angle I'm looking at, in this case I'm telling you to look at angle R. What I would probably do is like identify it, just kind of circle it, so I know that's the one I'm looking at. And then I would label the sides like, that's my hypotenuse. This side right here, that one's opposite it. And this is the side that's touching the angle, or the leg that's touching the angle. And that is the adjacent side. So that when I go to write these out, all I need to do is write what the ratio is in words, and then just replace the words with the numbers. Okay? Such as, by definition thing, I said like the sine equals opposite over hypotenuse. So if I said, what is the sine of R for this triangle right here, I'm asking you to actually write out, using the numbers, what the ratio is for that angle. So like I would go, okay, the opposite side is 45, hypotenuse is 53, that's it. Okay, and that's all I'd be asking you to do if I said write the sine of R. I'm not solving anything right now. This is just practice writing out what the ratios would be. And I go, okay, if I want the cosine of that same angle, cosine was adjacent over hypotenuse. So now I would go back to the triangle, because I already have them listed, because I'm not changing the angle I'm looking at. I already have them listed. I just go, oh, by the adjacent, I've got 28. 28 there. Hypotenuse is still 3. There's that one. and then tangent was opposite over adjacent. Okay, so again, we're not using this to do anything yet. Okay, all we're simply doing is setting up ratios. That's it. Okay, so opposite over adjacent. The opposite side, I still have listed as 45. Put 45 there. Okay, so if I simply said something like, what's the sine, cosine, and tangent of angle R, this is what I'd be expecting for answers. Okay, so the question asks, what are these ratios? Simply write the ratios out. Don't do anything else with it. I'm trying to remind you that at the end, because there's going to be something we do at the end that will make many people do too much work on this problem. Okay, and again, this would be me simply asking, what are the sine, cosine, tangent ratios for that angle? All right, and if I changed it, like if I looked at angle S now, obviously that would change the opposite and adjacent sides. Like if I looked at angle S, this would become my opposite side, that would become my adjacent. So some of these ratios would change. All right, now, the whole point of being able to set these up is again to find side length. Okay, because I said, like, everything else that we work with beyond this chapter is probably in one way or another getting broken up into right triangles. Because we have lots of ways to find side lengths of right triangles. So since there's lots of ways to find side lengths of right triangles, it's easy to break shapes up into it and find lengths with the tools we have here. Okay? Now, now, as you do the work, and again, this is just to find the side length stuff. I got just a few steps I'd probably suggest you do. And this would be problems where you've got a right triangle. They give you an angle measure, give you a side length, and they have like an X or a Y or an A, B, or whatever on the side length. So you would look at the problem and say, oh, I need to find the side length of a right triangle. Okay, if you have to do this. And this is, again, meaning like a problem where special right triangles don't apply or Pythagorean theorem doesn't apply. Like you can still use those, all right? You got to understand, by the end, guys, you're going to have 3 different things you can do. You can do trig ratios, special right triangles, or Pythagorean theorem. And I don't really care which one you do as long as you're able to find the correct side length. Okay? Now, but for the stuff today, okay, this is all taking into account that Pythagorean theorem is out the door, you can't use that, and special right triangles you're not being able to use. This is every other situation. What you'll do is you'll pick one acute angle. You'll know one of them, okay? But if you know one of them, you can find the other one just by subtracting from 90. It doesn't matter which one you use. All right? Once you pick the angle, you're going to label the triangle the same way I did that last one. Like when I circled angle R, and I went, oh, this side is opposite angle R, this one's adjacent angle R, and this one's the hypotenuse. All right? And the whole point of doing that is so that if you set up one of these trig ratios, you'll have the sides. Like if you did the sine in that angle, you would just have to look and go, oh, what's the opposite side, what's the hypotenuse, and fill them in exactly as was given to you on the problem. All right? So you pick the acute angle, you're going to label the sides in the same manner I did the last one, like we are. All right? And once you're there, what you're going to do is you're going to have 2 of the sides kind of given to you. Like one of them's going to have a variable on it probably, and another one's going to have a number. Okay, so if let's say you had the variable being the hypotenuse and the number was on the adjacent side, you just have to go, well, I'm trying to find the hypotenuse, I'm given the adjacent side. The trig ratio that deals with adjacent and hypotenuse is cosine. So at that point in time, you'd say, oh, I'm going to set this problem up using the cosine ratio. Okay? And then once you do that, it simply becomes just a proportion problem. And that's it. So since we're dealing with ratios, obviously we needed to do proportions, and that's pretty much all you're doing with these problems. All right? But once you do the labeling, you'll be able to see which type of trig ratios you're going to have to use. You just kind of go from there. right? Now, in order to do this, though, this is where scientific calculators, or if you don't have a scientific calculator, guys, I've got a piece of paper I can hand out to you so you can actually do some multiplication. Actually, honestly, let me give this to everyone. Yeah. The thing that's on this paper is mostly aimed at people that, like I said, don't have the scientific calculator with them. Each one of the trig ratios for acute angles, so acute angles being in between 0 and 90. Each one of the trig ratios for those angles, for all the acute angles, have a specific value for them. All right, on that paper, guys, I just gave you, it's giving you the decimal equivalent to each one of those angle measures, like for sine, cosine, tangent. The calculator does this for you. Like if you look at that chart, right? You go to the sine column, and I say something like, what's the sine of like 15 degrees? Okay, according to that chart, I would go to the sine column, go down to 15 degrees, and you can see 0.588. Okay, what this does, this is going to give you one side of that proportion. All right, so when you set these proportions up, one side is going to be this value, the other side is going to be the actual side lengths of the triangle. Now, in the calculator, if on your calculator you typed in sine of 15, you should get the exact same answer. If your calculator is not giving you that answer, it's in the wrong mode. We're going to have to change the mode for you. All right? But if you do sine of 15, it should give you that exact same answer. It actually will give you a lot more decimals than that, but usually when you do these, you go out to 4 spots just to set the problem up. All right? So if you've got a scientific calculator, guys, what I would do is I would check this. If this sine of 15 does not equal that, you need to let me know so I can make sure you're in the right mode. Yeah, I can see that different RU right there. It's a different way to do it. All right, so guys, I'm going to go through, probably like 2 of these, I'm going to have you guys do a couple. Okay? And the ones you're going to do are going to be in the book. Okay, so I'm going to go through the steps as I have listed out. Okay, we'll do the one on the left first. So according to the steps I had, the first thing said, pick an acute angle. Like I've got 2 acute angles. I've got this one and this one. Obviously the number's there, so I would assume most people are going to go to this angle as the one to focus on. All right, but it's, you know, it wouldn't be hard to find this one. That one's just 90 minus 23, right? So that'd be 67. So it's not like you can't use that. All right, so, but since the number's here, I'm going to stick with that. And I said, okay, once you got the acute angle, like kind of circle it so you know, oh, I'm looking at this angle. Then you're going to label the side, right? That's my hypotenuse, so this is the longest side. This is the side right next to it. It's the adjacent side. That's the opposite.
How do you know if the other one's not adjacent, the other one's not opposite? Because the rows connected, one before, you're like the opposite.
mean this side?
No, okay, so the longest is the hypotenuse, and the
Yeah.
second longest is the adjacent?
No, the one that touches the angle.
Oh.
Adjacent means next to. Okay, now, so here's the next step. Would be once you got those labeled, then what you're going to do is pick one of the trig ratios, right, according to what the definitions are, depending on which variable I want to find. Okay, so like, you want to find S or T first? T? That's fine. So if I want to find T, I go, okay, T is my opposite side. I'm given the hypotenuse. So I'd go back to all my ratios and go, okay, which one uses opposite hypotenuse? That one. The sine does. So the way you set these up is it goes sine of the angle, which according to the sheet or your calculator, this is going to be a number, right? This is decimal, equals opposite over hypotenuse, but actually put in the numbers, right? My opposite side that I have listed is T, hypotenuse is 4. Okay? What is the sine of 23? Give me a sheet, or what is it? 3907. Okay? Now, for the sake, guys, of understanding this is a proportion, right? That's over 1, just so you can keep your mind in thinking cross multiplying. Right? Because if I put that over 1, then I can see, oh, 1 times T, which is T, 34 times 0.3907 is whatever the value T is going to be. So what's 34 times 0.3907? 13.03. All right, so I know now this value, this side length here, 13.3. Okay? Which again, we couldn't have done this the past couple of days because this isn't a special right triangle, and I didn't start with 2 side lengths to find third. Now here's the thing, in this problem here, since I have 2 side lengths, if you wanted to revert back to the Pythagorean theorem to find the other ones, that's fine. So they're going to get you the right value, it doesn't matter. If I wanted to stick with the trig ratios, I would go, this other variable here is my adjacent side. The one I was given is the hypotenuse, so I go, okay, which one of these 3, sine, cosine, and tangent, uses adjacent and hypotenuse? That one. So my other one I would set up as cosine of the angle. Remember, the angle doesn't change because I'm only looking at one. That's the benefit of not switching them, is you don't have to change that number. All right? And then it's adjacent, right, over hypotenuse, and you just fill in what you know. Or was it 0.9205? And I'm putting that over 1, so that equals S over 34, and then just cross multiply. So S equals whatever 34 times 0.9205 is. 31 point. You get the same answer, guys, if you did Pythagorean theorem. Okay? Once you, if I've got a problem where you're finding 2 variables, it wouldn't be that big a deal if you did Pythagorean. Okay? Don't lose though.
You have to memorize everything.
That's I don't have another copy for them. Okay? Alright, let me do the other one real quick. You want me to just use the 70 that's there? Is that okay? So going through the steps, I'm going to say, okay, I'm looking at 70. Which one's the hypotenuse? B, right? Which one's opposite? 9, right? Because that's the one I can draw the arrow to. And this is the one that lies along it, so that's the adjacent side. Okay? All right, now picking, guys, just you got to remember, here's the thing. Most people always ask, how do you know whether to use sine, cosine, tangent? Even if we do a couple, that's always the question. The way you pick is always going to be depending on which one you want to find. Okay, like you want to find W or V first. W. So if I go, okay, W is my adjacent side. The one given to me is the opposite side. So the one I pick has to be the one that uses opposite and adjacent together. Which, out of sine, cosine, and tangent, which one was the one that used opposite and adjacent? Tangent. So I go tangent, 70 degrees equals opposite over adjacent. Right? Opposite side is 9, adjacent is W. Okay? Tangent is 70. 2.7. Again, I'm putting that over 1, guys, just for the fact of the matter of remembering that I'm cross multiplying. Okay? So when I cross multiply here, I've got W times 2.7475 equals 1 times 9, which is 9. How do I get the W by itself there?
Divide both of them.
Divide. So W is going to be 9 divided by 2.7, so 3.3. 3.3. So I know, okay, that's 3.3. All right? And then if you wanted to, like I said, if you didn't want to go back into trig stuff, you could go, I've got through the sides now. I'm doing this just to show you get the same answer. So I could technically just do Pythagorean theorem if I wanted to. That's fine. You're going to get the same answer. All right? I'm just bringing that up so that you understand, guys, everything we've done is to be applied here. Okay? All right, so if I did it this way, that's 81. What's 3.3 squared? And then, so b squared would be 91.89, and square root of that is what? The square root of that? Wait. And consequently, guys, that would have been the same answer you get if I would have done it with like sine. Okay? Same answer. Alright? These are the ones you guys can do for. Okay? If you have a scientific calculator, you'll note that there are those things listed generally right above the buttons, usually in a different colored text. These right here are the inverse trig ratios that you're going to use. These are used to find the measures of the acute angles in the triangle, given that you have enough sides. You have to have at least 2 side lengths in order for this to work. Okay, if you don't have 2 side lengths, there's no way for you to find the measures of these angles. It's probably a good idea. So, and generally, what you got to remember is you still need to remember the basic trig functions, like sine, still opposite or hypotenuse, adjacent, opposite or adjacent opposite. When you do problems like this, where they'll give you 2 side lengths and they say find the acute angles, find the measure of one of the angles, something like that, you still need to go about it the same way, where you still need to focus in on that angle. You need to identify which side's the opposite side, which side's adjacent, which one's the hypotenuse. But, okay? And then what you're going to have to do, and this is if you have the calculator, guys, these buttons right there are going to be what you use to find the angle. So just kind of keep that in mind. Like these right here, when you use these on the calculators, these find side lengths. This is the thing you're going to use to find angle measure. If you have to use the chart, you have to use the chart, guys, you can get within 0.5 of the correct angle that you're looking at. Obviously, like some of these angles aren't going to be exactly like 20. You might get an answer that's like 19.7. But if you use the chart, you should be at least be able to get it within close to that range at least, like 19.5 or 20 or somewhere. Okay? What you will have to do, because with the chart, guys, you need at least a basic calculator. You're going to have to do this division. Okay, like this is going to be the point where when you take the two numbers that fit into your ratio, you do need to make sure you divide those numbers out and get a decimal point. All right, and just always keep, when you're doing this part, guys, keep this in mind. Sine and cosine, when you set those ratios up, always have to be in between 0 and 1. Okay? The hypotenuse is in the denominator. Hypotenuse is the biggest side. If you ever are setting these up, you get like sine of A equals a number greater than 1, then you screwed something up. You probably just flipped the numbers on yourself. Cosine can't be bigger than 1. Tangent can. Okay? Because it doesn't have the hypotenuse in the bottom. Alright? So, types of problems where you might do these would be strong enough. Give me a number.
30, 17.
30?
30.
17. Okay. Let's just say I got a right triangle and I got one side that's 17, one side that's 30. And we'll call these like, this would be like P, this would be S. Alright, if I gave you that triangle there, and the problem said something like, I want you to find the measure of angle P. Okay? I would have to know first, like, this is the case that I'm going to be using, if I have a calculator, like scientific calculator, I'm going to be using these buttons right here. Because it's a right triangle, I have to find an angle measure. And when I have a right triangle and I'm finding an angle measure, I'm going to be using the arc sine. These are actually called like arc sine, arc cosine, arc tangent. So sine -1, cosine -1, tangent. There it is. If you hit on that.
Is it the one that says has the I and H?
No, yeah,
If you hit second, if you hit second, it'll pop up. What's up? Alright, so the way you should go about this, guys, is do it the same way you would have done the problems we find in the side one. Okay, where you go, okay, this is the angle. This side right here is my hypotenuse because it's opposite the 90. This one down here is the opposite one. And this is the adjacent. Because labeling them will still tell you which one of the three I want to set up. So I don't know the opposite side. The two sides I know are adjacent and hypotenuse. So since I know those two, that means the only option up here for me to use is cosine. Okay? And you would set it up exactly as it looks here. You would go cosine of the angle equals the adjacent side of the hypotenuse. Divide those out. Make them a decimal. Okay? So if I do that, so what I'm asking you to do is actually in the calculator do 17 divided by 30. And that gives you what? 0.5667. Okay? So here's the thing. If you've got the scientific calculators, guys, you can actually, in the calculators, put in, do the cosine -1, 0.5667. This will get you the measure of angle P. Okay? Is it 55.5? All right. If you don't have a calculator, Okay, what you would do is you just go on that cosine column until you see a decimal that is pretty close to this. All right? So you still need to be able to divide these out. So I said you still need a basic calculator. But if you just go to the cosine column, go until you see a decimal pretty close to this, that'll lead you over to an angle measure. I would assume this one should fall in between 54 degrees, or I mean 55 degrees and 56 degrees on that chart.
It says .5592.
Which one?
For 56 degrees.
What's 55? What's 55?
.5736.
Yeah, so yeah, no, 56 is 0.5592, right? Is that what it says?
Yeah.
I just heard 59. I didn't hear the first time. So what you would do, guys, is you would, like on your chart, you would realize this decimal is in between 55 and 56. So your best estimate would be 55.5. If you realize it's in between, guys, and I know you're using the chart, I'm not going to take off if you're off by like a couple hundreds. Like this ended up being 55.2, but you said 0.5, and you were using the chart, that's okay. Okay? As long as I know you were using the chart to make an estimate here, that's fine. All right? Because if you're using it, your best guess is going to be directly in between them, which is halfway. All right? So if you're doing this, you just have to find what angles this decimal will lie in between, and then just go halfway in between. That's going to be as close as you can get really with the chart. Okay? Like you could probably skew it a little bit more, but you don't really need to. All right? So this stuff works best with, obviously, a calculator.